Sometimes we need to use the normal distribution in sort of a backwards fashion. Let's take a look at this problem and you'll see what I mean. Here we're back at the gas station and the owner still has daily sales of 1,000 gallons per day and a standard deviation of 100 gallons. But now he wants to know how many gallons of gas should he have on hand to meet the daily demand 99% of the time. This is sort of a backwards problem because before we started with the number of gallons of gas and then told him what probability that would represent as far as meeting daily demand. Now we're starting with the percent of probability and we want to know how many gallons of gas, so it's sort of backwards. What value of x corresponds to 99% is really the question we're trying to answer. As usual, let's take a look at this graphically. Well, we have our z scale, we have our x scale, we have our standard deviations written in, but we really can't set a line for the x value because we don't know what x value we need. It could be here between 1 and 2, it could be up here between 2 and 3. We don't really know exactly where it is. We do know it's above 0 because it's 99%, and we know it's going to be pretty far to the right because 99% is most of underneath the curve. So if we were to fill it in, it would look something like this. Most of the curve would be filled in, and what was filled in would represent 99%. So somewhere up here, we're going to find an x value. Well, the way we do this is we work the problem exactly backwards from the way we worked the other one. Instead of finding the x value and then converting that to a z and then looking that up on the z chart, we start with the z chart. So here's a portion of a z chart, and what we're going to do is try to find 99% on the z chart. The key with this is we're not going to be looking down the left-hand side or across the top. We're going to be looking in the center area, which is highlighted in blue here, to find 99%. And very often you don't find the exact number you're looking for. In this instance, we'll find as close as we can. And when we look, we find 0.9901. That's the probability we're looking for. Now we need to look on the sides to see what z value corresponds to it. And when we do that, we see it corresponds to a z value of 2.33. Now we have our z value. Now let's go back to our formula, our z formula, and you can actually use the z formula exactly as it is and then plug in your z value, your mean, and your standard deviation, and then solve for x. To make it a little easier, I have already solved for x and rearranged the formula for you, so you're welcome to use either version of it. And when we put in the values, the mean, the standard deviation, and our new z value, we get 1,000 plus 2.33 times 100, which works out to 1233. In other words, if the gas station keeps 1,233 gallons in their tank, then there is a 99% probability that they will be able to meet the daily demand for gas. So once again, the way we work this is we start on the z chart, find the z value that we want, find the corresponding z numbers here from the percentage, then plug it into our formula and solve for x. So it's really not that difficult. You just need to think a little bit backwards on these type of problems.